Your goal after this video is to know what a linear expression is and how to add and subtract two linear expressions. Please take notes as you watch this video. If you lost the note sheet that I gave you in class, you can write on a separate sheet of paper. So a linear expression. Remember, an expression is like a math phrase. It's numbers, variables, maybe some addition, subtraction, multiplication, or division. So numbers, variables, and operations. A linear expression is one in which the exponent of any variables is 1. If there are any variables in the expression and their exponent is greater than 1, then that would be a non-linear or not linear expression. So we're going to look at this first example. That is a linear expression because there's only one x. So if we wanted to, we could put a little exponent of 1 on this x, right? If you see a variable with no exponent, you can assume that its exponent would be 1. Same with this one right here. X has an exponent of 1, x has an exponent of 1. So those are all linear because the variable has an exponent of 1. These nonlinear ones in the bottom row all have a variable with an exponent greater than 1. So in this first example, the exponent is 2. So that is not linear. In this one, yes, this last variable has an exponent of 1, but there's another variable with an exponent greater than 1. So that is not linear. And lastly, we have an exponent of 5, not linear. In the words linear and non-linear, there we go, you see the word line. Linear expressions, when you graph them on a coordinate grid, will form a straight line. Okay, a linear expression will form a straight line when graphed. A non-linear, or an expression without a line, will not form a line when graphed, not a straight line anyway. All right, find each sum. So sum means the answer when you add. We are going to add linear expressions. So here's one linear expression. We're going to add it to this linear expression. They're linear because the exponent of the variable is just 1. First thing you should do is make sure that the problem is all added. So take a second to write. Remember to pause at any time if you need more time before I go on. All right, so we're going to change to addition. So right here, I'm going to change this to x plus negative 2. Then we are going to get rid of the parentheses, because when you have an expression that's all adding, the parentheses do not change your answer. So we could quick look at this in this example. Don't write this down. 1 plus 2 plus 3 plus 4. All right? If we added those all up, we get 10. If we did groups and said do this first and do this second, we get 3 plus 7, which also equals 10. So parentheses do not matter. They do not change the answer when your expression is all adding. So we're going to get rid of those parentheses and just write x plus negative 2 plus 3x plus 8. All right. Another thing that doesn't matter when we're just adding is the order. So 1 plus 2 plus 3 plus 4 is the same as saying, I don't know, 1 plus 3 plus 4 plus 2. Still going to get us 10 either way. So we're going to also change the order that these numbers are in. That is called, when we do that, that's called the commutative property. Because if something commutes, that means it moves from one place to another. If you commute to work, it means you're moving from your home to your work in a car. If you commute to school, you're going from school. Or from home to school. You're moving there, you're getting there one way or another. So commute means to move. The commutative property, please write this down, tells us then that when an expression is all adding, our numbers or our terms can commute from one place to another. It doesn't really matter where, but I'm going to say, hey, I can combine these two things. So let's have them commute, or let's have them move so they're by each other. So I'm going to write x plus 3x. I'm kind of ignoring this part B right now because I need more room. All right, then I could say, all right, I can also combine these two. Ugly packer colors. Sorry about that. I hope you can forgive me. All right, So I'm going to put my -2 and my 8 by each other. Again, the order doesn't matter. I could write plus -2 plus 8 or plus 8 plus -2. Doesn't matter. Okay, now I am going to combine like terms. So please write that down. Combine like terms. So I'm going to say, all right, if I have an x and I get 3 more x's, how many x's do I have altogether? I have 4 x's. And if I have 2 negative ones and 8 positive ones, 2 negatives and 8 positives is the same as 6 positives. So I combine my like terms and I'm left with that. I can't take 4 x's plus 6 ones. So this is in simplest form. We are not going to do part B. So you can cross that out. Or you can try and do it on your own and see how it goes for you. But everything that I have written on this paper should be written on yours. As if you need more time, I'm going to go on. All right, so in the previous example, when we added 2 linear expressions, I told you the first step was to make sure it's all adding. And when I look at these linear expressions, here's a linear expression, here's another one right here. All right, I see that they're not all adding. We have a few problems. So my problems here are that over here I have subtraction. So I'm just going to change that subtraction to adding a negative. That's an easy fix. All right, becomes 5z plus -2. Then the bigger problem is that over here I have multiplying. Remember, a number next to parentheses means multiply. So we're taking 2 times everything in that group. We're going to distribute it. So 2 times that, 2 times the second term as well. So I'm going to write that. I have 2 times -7.5z. And I also have 2 times the second term, which is 3. This stuff over here is not being multiplied by 2. All right? So there I'm going to say plus 5z. I'm going to drop those parentheses because we don't need them, plus -2. So that was the distributive property. Now I'm going to evaluate that multiplication. So I'm going to say, okay, 2 times -7.5z is -15z. And 2 times 3 is 6. Just recopy the rest of the problem because nothing's happening there. Now it's time to use that commutative property of addition to get my like terms by each other. So I'm going to say, all right, 15 negative z's and 5 positive z's. I can put those together. So I'm going to rewrite my problem. I could write 5z plus -15z, or I could just write -15z plus 5z. Doesn't matter the order. I could have done the 6 and the -2 first if I wanted. And then I have 6 positives, 2 negatives. Okay. So I'll combine what I can. -15 z's, 5 positive z's. Those 5 positive z's cancel with 5 of these negative z's, and I'm left with 10 negative z's. If I combine my ones, 6 positives and 2 negatives makes 4 positives. So now I've simplified my expression down to just 2 terms, and that's as far as I can go. All right, lastly, find each difference. So this time we are subtracting 2 linear expressions instead of adding them. So here's a linear expression, here's a linear expression. Okay, so first thing we want still is to make our expressions be all adding. So I'm going to go through 5x plus 6. That looks fine. All right, then it says minus all of this. All right, so subtract all of that. So we're going to have minus -x. And we are going to minus 6. All right, does this make sense? We're distributing this negative. It says minus everything in the group. So we need to minus the first thing, and we need to minus the second thing. Okay, so then I'm going to go through and I'm going to say, hey, this looks ugly, but we know that subtraction is the same as adding the opposite. So I'm going to change subtraction to adding. The opposite of -x is +x. Okay, and that's the only subtraction symbol I have. So now I will use the commutative property to move my like terms by each other. So I'm going to do this. I have 5x's and another x. So we're going to make that 5x plus x. Then I have, let's see, I want a different color hat, right? Then we have 6 positives and 6 negatives. So I'm going to say plus 6 plus negative 6. Combine like terms, 6x plus 6 minus 6 is 0. So in other words, we could just say that the simplified version of this is just 6x. Please bring your notes with you to class tomorrow. I would like you to attempt part B. So attempt part B on your own, bring that to class tomorrow along with your completed notions.